Okay, we're going to look at the chi-squared test, which is used when you want to see if there's association or correlation between two categorical variables. In this example, we want to see if there is association between a student's gender and whether or not their political view is liberal, moderate, or conservative. Okay. So I give you some data that was collected on 214 students, and here's the data. And I want to see if there is association between these two variables for the whole population. So that's the question I want to look at. And I'm going to use my sample data to make my decision. Okay, so the hypothesis for a chi-square test is always the following. The null hypothesis is that there is no association or correlation between the variables. The alternative hypothesis is that there is correlation or association between the variables. Okay, so to test the claim, we first want to begin by assuming the null hypothesis is correct, is true, and we're going to see if we can find evidence against that. So we're going to start off by believing there is no correlation between gender and political leaning, and we want to compute what should be the expected count? How many people should we expect in each of these 6 categories if the null hypothesis is true? Notice I did many of the calculations for you already, but we'll do one of the cells together just as a reminder. So if I want the expected counts for moderate males, I'm going to go up and get the total number of males, which is 127, and the total number of moderates, which is 93, and multiply them together. So 127 times 93, and then I'm going to divide by the grand total or sample size, which is 214. So if you do that calculation, you should get an expected count for this cell of 55.19. Okay, you can have StatCrunch do these things for you, and I show you how to do that in the lesson notes. So once you have the expected counts, you're trying to assess, remember, how close is this table cell by cell to the observed counts? If they're similar, there's no reason to reject the null hypothesis. But if the corresponding cells in the two tables are very different, then we will reject the null hypothesis. Okay, so we need a test statistic to help us figure this out. It's no longer the z-test statistic. Remember, it's the chi-square test statistic. And what you do for each of the 6 cells is you take the observed cell count minus the expected, you square it, and you divide by the expected, and then you sum them all up. So for instance, you would take female liberals, 43 of them, subtract off the expected number of female liberals, 35.78, square that number, and then divide by 35.78. You do that same calculation for each of the other 5 cells. And so if you work that out, you should see that the chi-squared value is 11.42. So that's your test statistic, and now of course we need to get a p-value. So the chi-squared distribution is sketched out here. And remember, for this test, we're always doing a right tail test. So you want to mark off on the axis where your test statistic is. Ours is 11.42, and then we want to get that shaded area. That's your p-value. Okay, so to get the p-value, remember you need to compute the degrees of freedom. That's the number of rows in your table minus 1, which is 2 minus 1, or 1, times the number of columns minus 1, and that would be 2. So go to your table, go to row 2, and look in your table for your chi-squared value of 11.42, and you can see that it's right in between these two numbers here. Okay, so it's right in between here, therefore the shaded probability, the p-value, is in that region. So it's between those two numbers. Turns out that the p-value is exactly equal to, and you can get this from StatCrunch, 0.0033. Now remember, we were running this test at the 5% level, so we want to compare our p-value to the cutoff of 5%. So if you do that, you can see absolutely you need to reject the null hypothesis. Okay, and then you're just going to conclude then, if you're rejecting the null, you're throwing that out and you're concluding that there is correlation between gender and political leaning. So just remember the two conditions to use this test are that you have a random sample, which we'll assume that was true, and also remember that each of these 6 expected cell counts have to be at least 5, and they are. Okay, so that concludes a chi-squared test of independence.